This is video 512, and we're continuing on with verifying identities and getting some more hints to get us started and to create our list of hints for verifying identities. So let's take a look at this first example. We're going to start with the right-hand side because honestly these two sides are kind of equally complicated. So we're going to start with the right-hand side and see what we can do to turn it into the left-hand side. So I'm going to start by changing to sines and cosines. Secant is 1 over cosine. Tangent is sine over cosine. And the reason I chose the right-hand side, a second reason why I chose the right-hand side, is the left-hand side is already in terms of sine and cosine, so this I can turn into sines and cosines. So now let's take a look at how to simplify that. Notice they have the same denominator, so I can simply rewrite this as a single fraction over the single denominator cosine of theta. And you're actually finished verifying this identity because you've turned the right-hand side into the left-hand side. That was a short and sweet example. It looked kind of weird at first, but it turned quite nicely into what we wanted. Let's take a look at example number 2. Here's your hint for this example. Meet in the middle. So we've mostly been working with one side and turning it into the other side, but another strategy that we haven't talked about yet that I mentioned is that you can meet in the middle. What that means is I'm going to do a little bit on the left, a little bit on the right, and I'm going to meet in the middle. And it will create still a full loop from left to right, but we're going to meet in the middle somewhere. So I'm going to start with the right-hand side. I'm changing it to sines and cosines using my reciprocal identity. And simplifying that, I get 2 over cosine of x. So now I'm going to take everything on the left and try and turn it into 2 cosine of x, because I really don't know what else to do with the stuff on the right. So I'm going to leave that as is right now. On the left, though, lots of stuff going on. Notice there's 2 pairs of fractions being added. I want to make this into 1 fraction because that is what we see over here. So in order to do that, I need to get common denominators. Here's my denominators, 1 plus sine of x and cosine of x. So on the left fraction, I need to incorporate a cosine of x in order to have a common denominator. So I'm going to times by a clever form of 1 for both of these fractions. The right fraction needs 1 plus sine of x in the denominator to have a common denominator. So I'm simply timesing by a clever form of 1. Now I'm going to rewrite this as cosine squared of x. So the left side, the left fraction will get cosine squared of x. The bottom, I'm actually going to not multiply it out. And here's why. With experience, you'll get better at when to multiply it out and when not to. But the number one reason why I'm not multiplying it out is I see this single cosine of x, so I kind of want this cosine of x. And I'm really hoping that this 1 plus sine of x will cancel out somewhere along the lines. So let's see where it takes us. We can always multiply it out later. The right-hand side, I am going to multiply out the numerator. I'm going to FOIL it out. You can also use a generic rectangle, but I'm going to multiply out the numerator. 1 times 1, 1 times sine of x times 1, sine of x times sine of x. So I multiplied out the numerator, and again I'm keeping the denominator factored, just like I did the first fraction. Now I'm ready to add these 2 fractions together. I'm going to do a little bit of simplifying in the process. So I'm getting cosine squared of x plus 1 plus 2 sines of x, I'm going to combine like terms, plus sine squared of x, all over the same denominator. So we're closer, but we have quite a complicated statement here. But we do have, notice a 2 popping up. The 2 is promising because it's along the route of where I want to go. And we now have a single fraction. So again, it's along the route of where I want to go. So let's take a look at how we can simplify further and get rid of some stuff up top and make it simpler. I'm seeing sine squareds and cosine squared, so I'm starting to think Pythagorean identity. So sine squared and cosine squared add up to 1. So I'm replacing those 2 things highlighted in yellow with 1. Everything else I'm copying down. 1 plus 2 sine of x, all over cosine of x, 1 plus sine of x. So the top is much simpler than it was. Simplify that out again. 2. I end up getting 2 plus 2 sine of x. I'm going to pause here, remind myself of where I'm headed. I want 2 over cosine of x. So remember, I still want to cancel that stuff in the denominator. Now be real careful when you're simplifying things. With fractions, you can only simplify factors on top and bottom, which is why I left this factored and I did not distribute the cosine x out. The top, however, is not factored, so I'm going to factor it so that maybe I can cancel something. I'm going to factor out a 2 because I want a 2. I want a 2 in my answer. And each of those numbers, 2 and 2 sine of x, can be divided out by 2. And those two values are equal. The bottom stays the same, and now I see what I can cancel. I have common factors on top and bottom, and they simplify, they cancel out, and I get 2 cosine of x. So make sure that when you simplify fractions, they should have common factors, nothing other than common factors. Not common add-ins, which are things you're adding. They should be common things you're multiplying. So I've met in the middle because I'm not actually going to finish the loop and go all the way from here all the way back to 2 secant of x. I'm going to stop because I've actually met in the middle. These two pieces are in the middle of the left and the right hand side, and they're equivalent, so you are done. Let's take a look at another example. A common mistake, and this is our next hint, is to think that they're equal. So we're going to make sure that we don't think that they're equal. But what you are going to do is introduce what you want by multiplying by 1. And 1's in quotes because it doesn't look like 1, but we know it's equal to 1. So take a look at these two fractions. I want 1 minus cosine of x on the top. So let's introduce it on the left-hand side by timesing it by 1 over cosine of x times 1 over cosine of x. Yes, it creates it in the bottom, but you'll see real quick, and we'll talk a little more in class about why that's going to be so helpful and how that relates to something you've already done. So I'm introducing what I want. I want that in the top, so I'm going to introduce it. Now I'm going to leave the top factored because, again, I don't want sine of x on top. So somehow I'm going to cancel that. But on the bottom, I am going to distribute that out, FOIL it out, and get my factor, my entire answer in the bottom. So I simply have introduced what I wanted. Now I'm going to simplify that bottom, that denominator. Cosine x minus cosine x cancels. I'm leaving the top factored though, because I'm hoping to get rid of that sine of x, because then I'm closer to what I want. Take a look at the bottom now. The bottom, I want to have a sine of x, so somehow I have to introduce sine of x into the bottom. So, take a look at the Pythagorean identity. Since cosine squared is there, notice you can rewrite the Pythagorean identity by subtracting cosine squared from both sides. You get 1 minus cosine squared equals sine squared. So I'm going to replace 1 minus cosine squared of x with sine squared of x because they are equivalent statements. I've introduced sine because it's what I want in the denominator. So I'll get sine squared of x, the same thing in the numerator, so I'm just copying down the numerator, but I've replaced something in the denominator. Now I have a common factor on top and bottom. On the bottom I have sine times sine, on the top I have a sine, canceling the sines from top and bottom. I get 1 minus cosine x on the top and a single sine on the bottom. And I have ended with what I am looking for, and I have finished verifying the identity. So this is key. You're going to have to introduce what you want by multiplying by 1, especially when you're dealing with a lot of fractions. And again, practice kind of makes you so much better at this. The more practice you do, the better and more likely you are to be successful with these concepts. We have one more example and one more hint before you get to your checkpoints. So the final hint is whenever you are working with these trig ratios and functions, you want to make sure that you don't have different angles on the inside. So notice all of these have x, 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 except for this guy. It says sine of negative x. That's the first thing you should take care of. Take care of it so you have the same angles going on in your problem. So in order to do that, I'm going to use the even-odd formula. And I'm going to copy everything else down, but sine of negative x can be replaced with negative sine of x. So don't lose your subtraction. The subtraction copies, but sine of negative x replaces with negative sine of x. Simplifying that, I end up get tangent of x plus sine of x, all over 1 plus cosine of x. Now take a look at where we're headed. We're headed to tangent of x, which is the same as sine of x over cosine of x. Again, I'm not really sure what to do on this side, so I'm not going to continue doing anything and meeting in the middle. I'm just going to leave that and keep my eye on it and see how close I can get to finishing that way. So the good news is I have a single fraction, but I have tangent in there. So let's start by replacing that with sines and cosines. Sine of x over cosine of x plus sine of x, all over my original denominator. Now this is not good. We have a fraction on top and it's being divided by another quantity. So it's fractions within fractions. So let's clean this up by working with the top only for a little while and making it so we can add the two fractions together by getting like denominators. So I'm going to literally add these two fractions together. Common denominator is cosine of x. So sine of x plus sine x cosine x all over cosine of x. And it's still all over my original denominator of 1 plus cosine of x. So again, this is not very good. I don't want a fraction on top of a fraction. So I'm going to simplify this by remembering that dividing by a number is the same as timesing by the reciprocal. So dividing by 1 plus cosine of x is the same as timesing by 1 over 1 plus cosine of x. Those are equivalent statements. Now this really is multiplying two fractions, which is good. I can do that. And remember, it's simply multiplying across top and bottom, but before I do that, I want to think about whether I should distribute the bottom. Because of where I'm headed to having cosine of x in the bottom. I already have cosine of x in the bottom, so I don't actually want to distribute anything. So I am going to simply leave the bottom factored. I want to get rid of 1 plus cosine of x. The top, however, I'm just going to copy because, of course, timesing by 1, it doesn't change. However, I see where I'm headed. I see that I want sine of x, so I factor out sine of x from both terms. And that allows me to get 1 plus cosine of x on top and bottom. They will cancel, leaving me with what I'm looking for. So sometimes the kind of magic unfolds. If you've ever done a puzzle like Sudoku, it's the same idea. You start it, you get stuck, you keep trying, you go a different route, and eventually you land where you want to be. So those are your examples for this video. Here's your checkpoints. Again, the identities are there for your use. But simplify the expression on the right. Okay, start with multiplying it out, and then maybe use a Pythagorean identity, or perhaps change things to sines and cosines, but sines and cosines will be harder. So try a Pythagorean identity and see if you can turn it into one of these four expressions. Free response question, do your best to explain your steps. Try to explain what you're doing each time and what you started with, and use parentheses to help you denote fractions and whatnot. So good luck, and bring those questions into class.